Okay, good morning everyone. We're going to be teaching you about volume by cylindrical shells.
So if need be on Friday, just have somebody back here clicking on the screen when need be, okay?
Okay, so why can't we use discs and washers? So let's refresh. When we're using discs and washers, there is often two functions, but when using cylindrical shells, there's only one function. So we have to slice perpendicular instead of parallel.
We have to slice, for cylindrical shells, we have to slice how?
We have to, so if it's this is a bad drawing. So that's for discs and washers. But when we're given a function for cylindrical shells, we have to go this way. Because if we only hit the function once, so
okay, could you just back up 1 second here? When you slice this way, and if you could take the blue marker and slice going across that way, nice and level, what's the matter with doing that?
Because you're hitting only the function slice instead of a different number.
You're hitting the same function 2 times.
Yeah.
Your big radius, your little radius are the same thing. Okay, so that's why some things don't lend themselves to discs or washers. And so, Crystal, instead of slicing perpendicular, how would we have to slice?
parallel.
Parallel to what?
Parallel to the y-axis.
Yeah, we rotated around the Y, but now we got to slice parallel to the Y.
My bad. Okay.
You want me
Yeah.
to advance?
It's gonna erase it.
Oh.
And then there we go. Matching back up.
So the first step is you draw a picture. So if we have a function like this, then that's your first step, yeah. And if you're rotating it around, say, x equals 0, then it would be around this way too. And so what you do for the radius is technically, this part is the radius, that x right there. So what you do is, if it's from the axis of rotation, if the original function is on the right, like here it is, then be x minus whatever the axis of rotation is. If it's on the right, if it's on the left, if the original function is on the left of the axis of rotation, then it'll be the axis of rotation minus x. And the height is actually a function. This is the height. And you put that into the equation, and you get the volume of the entire thing.
So that equation right there is how you find volume using cylindrical shells.
Yeah.
Okay, and we need to have, now how do you find volume? Volume is always the integral of the area, correct?
Yeah.
Okay, what is the area of a cylinder?
Well, this is the circumference of the cylinder, this is the height, and this is the thickness of the cylinder. So when you multiply those together and take the integral of it.
Okay, could you mention words radius and height? Could you write an integral that says 2 pi RH, please? And that 2 pi RH is the area of a cylinder, right?
Yeah.
Okay. Could we pull the 2 pi out front?
Yes.
So what we need is we need a radius and we need a height, correct?
Yes.
And that's what we're going to focus our attention on, is finding that radius and that height. Now, why do you say the radius is x? Could you draw on your drawing? Could you draw a cylinder? And now maybe using a different color, could you show us where the radius of that cylinder is? Okay, and so the radius of that cylinder goes out to some x value, because it could have been drawn many places. So that radius is x. Where is the height of that cylinder?
The height is the function because it changes as it goes.
Could you draw, no, the height of the cylinder
Oh.
is right here. It's this line right here that you drew. Remember, that's why you drew the cylinder. Could you take the green marker and draw this height right here? Okay, that's the height. And isn't that height the height of the function?
Yeah.
Yeah. So we need a radius and we need a height for this cylinder. Okay, and maybe as we do an example, that'll become more evident.
So it's my turn. Okay. So the first thing I would do is draw onto this beautiful picture we have, little cylinder. Then I would find what the radius is, which is x in terms of x, and it's x. Then I would find the height, which is in terms of y, which would then we'd have to translate it into x, which we have this equation, which would be 4 minus the x minus 2, that all squared. The circumference is 2 pi r, which then equals 2 pi x. Then the shell volume, which the equation would be 2 pi from A to B radius times height dx, which then we would just put those into the equation, which would then equal 2 pi from 0 to 4, the radius of x, which would times it by 4 minus x minus 2, that squared dx. Then it would be around 134.041.
And you got that by just putting that into your calculator?
Yep.
Okay. Now, first of all, you have a very nice drawing there, but we never rotated this around the line x equals 0. Could you maybe draw this thing using the red marker, since the original figure is red?
Okay. Something like that.
Yes. Okay. And what we're doing here is we're gonna use a cylinder. A cylinder, now, maybe take the black marker and draw the line right here, right straight down. Okay. Now, where's the other part of that cylinder? Wouldn't that be over here?
Yeah.
Okay, draw that one as well. And now draw the cylinder that goes from one of these to the other. Okay, so there's that cylinder. Now, could you use the green marker and show us the radius again?
The radius would be this thing.
Let's go all the way to that black line, all
Black
the way
line?
to where the cylinder isn't this wide right here.
That one?
Yeah, the cylinder is just this line all the way to this line over here. This is the cylinder here, not all of these blue lines right here. So the radius just starts at the center and goes out to that black line, and that's the radius of this cylinder. How many cylinders are we making?
Well,
How many? An infinite number of them. We're making an infinite number of cylinders. We're only drawing one. We're making an infinite number of them. Okay? And they all have a radius. And why does this start at 0 and go to 4? how do you get your lower and upper limits?
Look at the function.
The original function or the whole picture?
Original.
The original function sets the limits for you. And since this cylinder that Andrew drew, since it hits the x-axis, everything better be in terms of
X.
x. Everything's in terms of x because the cylinder that we drew hits the x-axis. Okay? And question.
How do we take account, like if it's just 0 to 4, how are we taking into account for all the area that's in the negative side?
It's using the radius, so it would be for the volume, you're using radius, not diameter. So it's just using half, just the radius.
So x was the radius, and x's, the radius can only be as big as 4, right?
Mhm.
Be as little as 0 up to 4. So yeah, good explanation. Next slide.
Yeah.
Yep.
Okay, so for this function, we're rotating it around the x equals 1 line. So we gotta draw it overlapping like this. So first you're gonna take the well, you're gonna draw the cylinder. So we're gonna find the radius, and that's just gonna be. So since we're going around the x equals 1, we have to account for that it's not around 0. So we're gonna have to do x minus 1 because the radius. So we have to take into account because it's already adding 1, so we have to subtract it in order for it to just be the plain old x.
Lauren, could you maybe start right in here and draw a radius?
Oh,
It starts
yeah.
here and goes out to your blue line.
Yeah.
There's a nice radius. And we gotta figure out how far that is.
Yeah. So we have to make sure that we get it back to 0. So since we're going around the x line, or x equals 1 line, we have to like get rid of that so we can just get the plain x radius.
So to find that distance, you just took big minus little, right?
Yeah.
Big is x, little is 1. So big minus little, that radius is gonna be x minus 1. Because we don't know what that x value is. Could be a lot of different things in here. So this is x. The cylinder is always drawn at x, but in this case, it's going back to 1. Cool.
Okay, so then we have to find the height, which is the function. So the height just x minus 3 squared times x minus 1. And then the circumference, as before, it's just 2 pi rh, which is 2 pi radius.
Circumference is just 2 pi
Oh!
r.
My bad, no height, my bad. So then x minus 1. Yeah, okay, so then the function, since we see that it's from 1 to 3, we're going to put it, the value is 2 pi times the integral of 1 to 3, and then we just put in our radius times height, so that's x minus 1 times x minus 3 squared times x minus 1, and then dx. And so then, does someone want to put that in their calculator? Because I did not put that in my calculator. Anybody? Anybody? Just go for it. Yeah.
6.702.
Okay. And then that's
That's 6.703.
yeah.
Okay. Now, for this cylinder right here, great idea to draw the cylinder. And great idea to draw the radius. And that way it's a little easier to see. The radius is x minus 1. And it's a little easier to see that the height, yeah, is always just the function right here, isn't it? Okay. Cool. And once you set up the integral, the 2 pi, radius, and height, then you just put it into your calculator.
Yep.
Next slide.
Yep. Alright, so what if you have two functions? So, once again, we're going to rotate it around x equals 7. So, we're going to draw our axis of rotation right around here. And then we're going to rotate this around there. So that's... Wait. Yeah. That's a really bad drawing, but whatever. Okay, and so then next up, we're gonna draw our cylinder. So, that, and then rotate it around. I'm not going to college for drawing, so we're fine. So then your radius is going to be from the axis to over here. So you're going to take, for radius, big minus little, so that's the axis minus x. And then for the height, that's this right here, which is the bigger function minus the little function. So,
And this is all this information comes from the original figure. You draw your radius back to the original. Cool.
So bigger function is -2 times x minus 5 squared plus 5 minus x minus 5 squared. And then your circumference is 2 pi times your radius, which is 7 minus x. And then the shell volume is going to be 2 pi times the integral from your left bound to your right bound. So if someone could plug those functions in and find the bounds, because it's some decimal.
So we got to find these intersections in this case, and only for the original figure, correct?
Yep.
Yep, the lower and upper always come from the original figure.
You good?
So why did the green function shift up?
Because I can't draw.
Okay.
He's an art drawing professional right
Yeah. That's just my horrible drawing skills. Don't. I don't want to hear it.
now. He's going to art school, guys.
Yeah. Alright. So, does anyone have the bounds?
The first one is at x equals 3.709.
Alright.
Yes, very. I haven't seen it. Oh, man, it's written on my face.
And then the other one is 6.291.
Alright, and then you're going to plug in your function. So, 7 minus x times -2 minus 5 squared plus 5 minus
Yeah.
squared dx. And then that comes out to...
It's okay.
Calculator, count again. It's fine.
It's fine.
Order of operations means I can do that because that's addition and subtraction.
That's the point.
Yeah.
It's fine.
It'll come out to the same answer, Jay.
Or will it?
It's like 180 something, right?
Some amazing answer.
Yeah.
It's definitely a whole number.
Is that upper limit 6.291 or?
Yeah, 6.291. Yeah, we're gonna have
Sorry. 117.167.
Alright. Jump. Circular shells. Cylindrical shells. Woo.
That's what they do.
Okay, we good?
Wait.
No,
No.
we are
what?
waiting.
What's wrong?
It's 180 for, yeah, that's it for Wednesday.
Yeah, I got 108.
I did this last night.
You
It's
guys
108.
Where-
stick out what
where
went
are we
wrong,
going
'cause That's
wrong?
the same exact integral that
Wait,
she put up.
Maybe I typed it wrong.
Yeah, I might have forgotten
Because
parentheses.
3 of us get 108, so I don't think it's wrong.
Okay, it's good up here.
Yeah, let's get up here. This might be there.
Use your
These are. Are you sure you're in what? degrees?
It
Radians.
wouldn't matter.
Yeah.
Yeah, look at this pie.
We're not
It's
using
just
sine
a-
or cosine or tangent.
4 of us get 108.
Yeah.
The answer should be 108.154.
Yeah.
Okay.
Well, I typed something in wrong, too. I got 117-ish.
I got 117 again.
Yeah.
I think it's
Yeah, probably the parentheses.
Yeah, probably.
Since there's no sines or cosines, mode shouldn't
you-
matter.
Yeah.
Or does it?
Put another.
Yeah.
Everybody else get 117-ish?
The parentheses.
Is the times 2 applied to the plus 5, maybe? Is that what we're doing wrong? Is negative
no.
2?
No.
Here, I'm gonna do this for you.
No, because now there's an extra.
Then you
Yeah,
gotta
that
add-
parentheses is
No.
really
Yeah, then
important.
erase that one.
Yeah.
Okay.
Oh, okay.
Let's see if I can do this.
Okay,
Okay, line.
anything else to present other than
No,
coming up
no.
with this answer?
No.
The
We're good.
presentation is done.
Yeah.
6.291.
And this way you may stop the recording.